And welcome back. I am so excited to finally kick off this brand new series we are calling 10 Days Building on Base. Now, I know you might be thinking, 10 days? That sounds kinda intense. But the Web3 Compass community is used to something even more intense. I hope you have not forgotten about 30 days of solidity. Come on, you cannot. And honestly, you're not wrong. It is going to be a little intense, but in the best way possible. Think of it like a mini boot camp that meets a super creative playground where by the end, you will be building stuff you don't even know that you could. Over the next 10 days, we are going on a journey together. We're starting from absolute zero, like probably never ever deployed a contract before on base, kinda zero. And we will climb our way up to building actual production ready applications. And I don't mean those random toy projects that just sit in your GitHub. But we're talking about things that people actually use. Now, what do we expect today? But okay. Before that, a little more context. As on the screen, you could see, okay, 30 days of solidity is ongoing with this base batches preparation. This time, we've brought it in collaboration with Dev3 Pack and a base blockchain itself. And yes, this is the entire 10-day curriculum. It starts on October 14th. And yeah, we'll be doing a lot of fun stuff together. Cool. So we'll start off today with deploying your very first smart contract, and then we will level up real fast. So you got to be prepared. We will build social mini apps on Base, explore gasless transactions because yes, you can make transactions without users having to pay gas, and even experiment with cross-chain communication. So yeah, buckle up. Grab your laptop, maybe some coffee, coconut water, just water, because this next 10 days, it's going to be super intense. Okay, so for day one, here we go. This is where it actually really begins. Think of today as our typical origin story moment, the part in every superhero movie where they're just figuring out their superpowers before they go out and change the world, except in our case, the superpower is building on Base. And I'm not sure if you have seen the hype around Base and people going all crazy over building mini apps and when I say mini apps, it's all kind of apps. It could be games, it could be social, it could just be maybe what? It's on you to think, because anything and everything is possible when you're trying to build a mini app on Base. So we'll talk a lot about it. But today is all about setting the stage. I won't immediately push you to all the jargons in the ecosystem and be like, hey, here we are coding 1,000 lines. No, we won't do that. So let's start small. We're going to answer some big questions like, what is Base really? Beyond the buzz, beyond the branding, beyond it taking over the entire crypto Twitter, what are we actually building on? And more importantly, why is Base such a massive deal for Web3 developers right now? Why are people calling it one of the most builder-friendly blockchains out there? So actually, don't worry. It isn't going to be that long, and it's not just going to be all story session or theory heavy session where you just sit and listen me yap. By the end of the session, we'll build something super simple, but you actually do something. You actually deploy your first smart contract on Base, check and verify it on BaseScan, and see how things work. Okay, so whether you are a developer looking to explore new ecosystems or someone who's just dipping their toes into the blockchain for the first time, you are in the right place. And this is where it starts, our first step into the Base universe. So let's jump right in. But also, we have tons of opportunities. This is not just going to be a 10-day tutorial series where we ask you to build so many things and then push nothing out of it. No, that is not how it is going to be. And I'll take you through that. So out of all the opportunities that we are talking about, you will, okay, let's just start small. Let's go to the base doc, okay? It talks about multiple things, global economy, creator tools, blah, blah, blah. We'll come to this later. And here. So this ecosystem has a lot of builder rewards going on where you get rewarded up to 2 Ethereum weekly through their builder rewards program. Then there are grants which are like, if you are building something super cool and you want to take it further, so you can apply for this fast retroactive base builder grants, which can give you access to 1 to 5 Ethereum. Then there are base batches, and this is actually the preparation for base batches. So a global program for builders where, there are tons of opportunities. For this one, which is the second version of base batches, there are 2 tracks, startup track, builder track, and you can read all the information. It has already started and it goes on to from September 19 to October 17, and accepted teams get notified by October 24, demo day at Dev Connect, which is happening in Buenos Aires on November 19. And then there's a global buildathon which goes on till October 24th, and that is the placement of the entire program. So it starts from October 14 to October 24. So you can learn and build with us. Yeah. And you can look into all the other information, but let's come back here, right? So this is the calendar. This is how you get all the information around what we're going to do. And everyone who is familiar with Web3 Compass pattern already, you know that we'll do a bunch of videos for, these days, and a lot of written content as well. But okay, no distractions. Back to the real content. What is Base? When you search about it, you will see a lot of terms. OP stack, Coinbase, testnet, mainnet, Sepolia, Base Sepolia, blah, blah, blah. So let's start with $1 million question. What is Base? I think I've said it a lot of times, but anyway. In the simplest way possible, Base is an Ethereum layer 2 blockchain and is incubated by Coinbase. Now, if you just heard those words and went layer what now? Ethereum who? Don't worry. I totally get it. When I first started learning about this stuff, I felt the exact same way. So let's break down together in a way that actually makes sense and no confusion, only clarity. So here's the easiest way to think about it. Ethereum, you can think of as a super popular highway. Everyone wants to drive on it because it's secure, reliable, and it connects to the best destinations in Web3. But here's the catch. Since everyone and their grandma wants to use it, the highway has to get crazy congested. And I'm talking bumper to bumper traffic all day long. The traffic that here in India, maybe Bangalore and Gurgaon people know about, right? So, and when that happens, highway gets that crowded, right? The toll prices skyrocket. On Ethereum, these toll prices are called gas fees. And they can get so high that you end up $50 just to send 20. That is wild. Why would I want to use it? So, what's the fix? That's where layer 2s like Base come in. Think of Base as a brand new express lane which is running alongside the main Ethereum highway. It is still connected to Ethereum, but it handles a bunch of transactions off the main road, processing them faster, cheaper, and way more efficiently before settling everything back on Ethereum for security. So in other words, Base gives you the best of both worlds. The rock-solid security of Ethereum, but without traffic jams, without the ridiculous tolls, and without the road rage. Pretty sweet, right? Now, this is where things actually start to get really interesting, especially if you're into tech side of things. Base is built on something called the OP stack, and trust me, this part is so cool. Once you really understand it, that you would not want to stop yourself building on Base. So the OP stack, which is short for Optimism Stack, is basically a standardized open source toolkit created by the team behind Optimism, another super successful Ethereum layer 2 network. Think of the OP stack like a giant box of Lego bricks, but these aren't your regular toy store Legos. These are specialized blocks made specifically for building very powerful layer 2 blockchains. Instead of reinventing the wheel or building everything from scratch, you can just snap these pieces together to create something which is super secure, scalable, and completely Ethereum compatible right out of the gate. By using the OP stack, Base inherits all the best stuff automatically. Battle-tested security, technology that's already proven to scale, and seamless compatibility. With everything that already exists in Ethereum ecosystem, that means all your favorite tools like Ether.js, Web3.js, Hardhat, Foundry, and for the love of God, Solidity, they just work. You don't have to learn some new alien stack or start from zero if you've been building on Ethereum. You are building on something familiar, which makes development super fast, smoother, and honestly a lot more fun. And then there comes the involvement of Coinbase, which takes everything to a whole new level. Coinbase, as most of you probably know, is one of the biggest cryptocurrency exchanges in the world. We're talking millions of users, a publicly listed company, and a massive reputation for trust and compliance. So their backing gives Base the something most blockchain projects only dream about, which is legitimacy, resources, and reach. They are not just funding it. They're bringing in developer support, infrastructure, and most importantly, a direct bridge to millions of users. Now, a lot of you might be thinking of skipping this and be like, hey, why do I care? Yeah, maybe. Why do you care if you just want to build? But coming from a development background, I feel like with the current Web3 space, with so many chains doing such amazing job, why should you go with one? Why should you go with a particular one? Why should you put in your time to build something? You need to know the backstory of it. Like, come on, think of it as a good night story. You should know. You should not be, if tomorrow I ask, hey, okay, cool, you've built mini apps in Base, but do you know what Base actually is, or who backs Base? And you're like, maybe, I don't know. So, okay, some general knowledge is important. Okay, coming back to it. Now, most blockchain projects struggle with user adoption. They build amazing tech, but no one uses it because onboarding is a nightmare. Or people just don't know that it exists. With Coinbase behind Base, that problem practically disappears. So you suddenly have a built-in audience of millions of crypto-curious users who can seamlessly move into the Base ecosystem. So when we put everything together, Base aims to a few key things. It is secure because it's leveraging Ethereum's tested security model. It's cheap with transaction fees. It's just a fraction of what you would pay on mainnet Ethereum. We're talking cents instead of dollars, and sometimes even fraction of cents. It is fast with transactions confirmations happening in seconds instead of minutes. Super developer friendly. It's super easy to build, very familiar tools, blah, 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 great documentation. So, okay. Beyond all technical specifications and buzzwords that everyone loves throwing around, what truly makes Base exciting and what really gets me pumped up when I think about it are the opportunities which we've already talked about that it unlocks for builders like you and me. So Base as an ecosystem has a place for everyone. Developers, creators, be it artists, musicians, anybody can hop in and find their place in the ecosystem. Now, I know that I've already talked about the opportunities here, but some of you might just be thinking that, hey, okay, Sneha, all of this sounds great, but I don't have funding to build full time. Can I just quit my job and work on this? Well, I've got really good news for you. Base has this incredible support system for builders. There's Builders Reward Program, which I already showed you on the screen. Then there's base batches and there are multiple tracks for it. So yes, you should build on Base. Now, before we jump into the coding and the fun hands-on stuff, which you guys are waiting for, or would have probably skipped, let me quickly explain two more concepts that you're going to hear a lot, which is testnets and RPCs. When we're building and developing, we definitely don't want to play with real money, right? So imagine you're learning to drive a car. You don't just immediately get started by driving on the highway in rush hour traffic or a thunderstorm. You start in an empty parking lot, probably with an old car, hit a corner too, and it doesn't matter. So that is exactly what testnets are, and I am assuming most of you would know it, but it's my duty to still tell you. Testnets are essentially practice environments. They're functionally identical to the main base network in how they work, but the only difference is we use play money and not real money, or test ether is what you can say. So it allows us to deploy contracts, test our applications, experiment with different ideas, break things spectacularly, fix things, basically learn without any financial risk whatsoever. So if you mess up on a testnet and somehow lose all your test ETH, really, who cares? Who cares? Now, coming up to RPCs, RPC stands for Remote Procedure Call, and if that sounds technical and intimidating, let me put it in simple terms. An RPC endpoint is basically the phone number that our application uses to call the blockchain and ask it to do things. Want to read some data from a smart contract? You call the blockchain through the RPC. Want to send a transaction? RPC. Want to check someone's balance? RPC. Want to get the latest block number? Also RPC. So it's sort of the communication layer between our code and the blockchain, and we will be setting up those as we configure our development environment, and I will show you exactly how to get your own RPC URL from Alchemy so you can follow along. If it sounds a lot right now, don't worry. Don't worry, you have my support, and I promise you it will all click into place when we start actually coding and seeing these concepts in action. It always does. Come on. No rocket science. Okay. So now we will just get to, okay. So we will get to any IDE that you're using. Generally recommend to use Visual Studio Code, but now I am so hooked to Windsurf, so that is where I do all my things. Now generate a new project, and I will say 10 days of welcome back. Caps lock issue. Okay, so we are in CD, 10 days of base. Okay, so what do we do next? So we'll be using, first things first, we need to install Foundry. So open up your terminal. If you are on Windows, I highly recommend WSL, which is Windows Subsystem for Linux. You can use Git Bash, but if you are on Mac or Linux, you can just use your regular terminal. I will just use the Windsurf terminal here, and I'll paste the command, and it says curl l foundry.paradigm. Okay. So now, what this is doing is it's downloading the Foundry installer script from paradigm.xyz and immediately piping it to bash to execute it. Now, you've seen the process has started. You'll see a bunch of outputs scrolling, which you can see on the screen right now. Depending on your internet connection, the speed might differ. And once that finishes successfully, you will need to run one more command to actually install the Foundry tools, which is Foundry up. God save me. Okay, cool. So this is how the installation looks like. Okay, now it will install and update all Foundry tools. You could see it install Forge, which is the main tool we'll use for compiling and deploying, Cast for interacting with contracts, Anvil, which is local Ethereum node, and Chisel, which is Solidity REPL. Don't worry about what all these do right now. We'll learn about them as we go. And now that we've got Foundry installed, we'll do what? We'll create our first Foundry project, and we're going to use the forge init command, and it says forge init first base project. So inside this, I don't know why did I create this. Okay, so that is okay. Let me check. What did I do? My first base project. Great. So now, if you actually look at this, there are certain, how do I say, template or boilerplate. It's like a starter template. You will see it creating a SRC folder for our smart contracts and a test folder for our tests, a script folder for scripts, and so many other things. Okay. So we will go to each one of this, but and we'll talk about what each one of it is doing, or maybe not, depending how much time permits, but we'll definitely talk about the important things. So, okay, there's some readme on how to go about it, but interestingly, there's a source file which has a Solidity contract called counter.sol. Now, there is a script folder to run it, and then there is a test folder as well, and you have to notice everything that's on screen. This is counter.sol, counter.s.sol, which is for scripts, counter.t.sol, which is for tests. Then there's a foundry.toml file, which is our configuration file. And here's the SRC folder that I mentioned and a few other things. This is going to be your project structure, and we'll be working in here for the rest of this tutorial. Now, something that we really need to do is we need an RPC URL to connect to the base Sepolia testnet. Remember how I explained earlier that RPCs are like phone numbers. So now what you will do is open Alchemy, and you have to go get in RPC URL for base here. I already have it generated. Okay. So now, okay. Cool. So we're saying first endpoint, 1 second. I want to create a new app. Okay, so you go and create new app, and here you can give whatever description you want to give. For example, probably my first base project or whatever you want to do. And then description is optional, use case you can give in. Okay, let me just base, batches, description, blah, 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 use case social, next. So now you have to choose a chain here, and you will see so many options, but then there's base. So you go next, and then, okay, NFT API, blah, blah, blah. Okay, so we are here, and then there's base. Where was base? Okay, so there are two options, mainnet, Sepolia. Click on Sepolia, make sure you change it here. Now you'll see the chain ID, network enum, everything changing. And then there is a API URL here, which you can just copy and use it like as a if you click on the section, there's like API key or RPC URL or HTTPS endpoint with a button that says view key, or I think Okay, so there's a app dashboard and there's connect RPC. So when you change things here as well, there are multiple ways to find it. Then there's https dot slash slash Sepolia, blah blah blah. You could see the same API key angle here as well. So you just copy it, and now what you have to do is actually come to this particular folder and create a .env file. Now I will do it off screen. Okay. And what you have to do is in the document that we've provided, you have to go create base Sepolia RPC URL equals to, and you have to paste the base RPC URL. But obviously you have to replace your Alchemy URL here with the actual URL that you just copied from Alchemy. So it should look like, okay, whatever it should look like. I will not show you that. And make sure that there are no spaces, the equal sign, make sure the URL is wrapped in quotes, hit enter. Now this creates an environment variable called base Sepolia RPC URL, which we can reference later. And for a permanent solution, you could also add it to your dot bash rc or dot zshrc file, depending on what shell you are using. But now that we are done with this, I'll replace it off screen. And there are other things that you might need in the .env, which I cannot show because it's private. It should not be revealed. Okay. So now what we'll do is that we want to do something different. We don't want to go with a counter contract, and we'll not write something super complicated as well, but we'll write something which is not a counter contract, but not super complicated. It's a greeting contract. I love to greet people, and that is why we'll write a greeting contract. All it does is store a message like a greeting, and it allows us to change that message and read it. Super simple, super straightforward, but it demonstrates all the core concepts of how smart contracts work. Let me type this out and I'll explain every single line as we go, and you really understand what's happening. But for that, we will remove this counter contract. We will rename it as greeting. Oh my god. Greeting.sol, and we can delete the script folder right now. It's not relevant for test, also not relevant. Otherwise, we'll have to make a lot of changes. Okay, so we are at greeting contract. Everyone knows the first line is SPDX license identifier MIT. Right? Now, what is this? Tell me, guys. This is a license identifier. Basically says, hey, this code is open source and you can use it under the MIT license, which is one of the most permissive open source license out there. It's a good practice to include this in all your smart contracts, especially if you're going to make them public or share them. It helps avoid any ambiguity and also about how people use your code. The next line, I know all the community people know what I'm going to write. So yes, we'll write the pragma, solidity, and we'll probably use a 0.8.0 saving. So it specifies the version of solidity compiler that we're going to use, and I know everyone knows that Solidity is the programming language for writing smart contracts on Ethereum and Ethereum compatible chains like Base. The little caret symbol arrow means compatible with version 0.8.0 and R, but not 0.9.0. So we're locking in the 0.8 series. And now we actually go define our contract. So we say contract greeter, and then this tells Solidity, hey, we are creating a new smart contract and we are calling it greeter. Everything we write between the opening curly braces and the closing curly braces at the end is part of our greeter contract. It's like defining a class in object-oriented programming, if you are familiar with that concept. If not, you need to read it now. Inside our contract, the first thing we're going to do is declare a state variable. So we will do, okay, great suggestion, Winserve, string public greeting. Yes. So let me break this down as well. Every word here matters. A string here is the data type, and it means that this variable is going to hold text, like actual words and sentences. Public is what we call visibility modifier, and it's pretty magical. When you mark something as public, Solidity automatically creates a getter function for you to read it. You don't even have to write that function yourself. And greeting is just the name you are giving this variable, though you could call it literally anything you want, like message or welcome text or even banana if you really want to. Though that would be confusing. So we will use write variable names here, and this is going to store our greeting message. And here's the cool part. Because it's a state variable, it gets permanently stored on the blockchain, not in some database that could get hacked or deleted, but on immutable decentralized ledger that exists across thousands of computer. Pretty wild, but when you really think about it, it's cool. It's sort of cool. Now, next up, we need something like a constructor. We could skip that as well, but I honestly like writing constructors. So it's a special function that has one job and one job only. And it does that job really, really well, like exactly once. So once the contract is first deployed on the blockchain, this never runs again. It's like the birth moment of your contract, the opening ceremony of your contract's life. So what are we doing here? We're basically saying, hey, when someone deploys this contract, they need to provide an initial greeting message. And this message gets passed in as underscore initial greeting. So the underscore is just a naming convention that we are using here. And now you might be wondering, what is this memory keyword? It's actually pretty straightforward. It's telling Solidity that this is a temporary variable that only exists during the function call. Once the constructor finishes running, the underscore initial greeting variable just poofs out of existence. But we've already saved its value to our permanent greeting variable, and that is what this line says. So greeting is equals to underscore initial greeting. Yes. And whenever the initial message was provided and storing it permanently. Now let's write a function that allows people to actually change the greeting after the contract has been deployed. Okay, cool. Did I give an extra curly brace? Yes, I did. Sorry. Okay. So we say a function set greeting. Okay, you know what? I don't know why it happens when I'm recording. But yeah, function set greeting. This is pretty straightforward. Again, string, yes. But with a memory keyword, this always comes in together, and we say new greeting in public. You know the meaning of all of these, right? So what do we do here? What is the point of having a greeting when you can never update it? So it would just be stuck saying the same thing forever, which is sort of boring. So this creates a function set greeting, and it takes one parameter, which is the new greeting message that someone wants to set. The public keyword, again, literally anyone can call this function, your friends, random stranger on the internet, blah, blah, blah. And as simple as that, is what we call a write function. And what we're going to do here is also going to say greeting is equals to new greeting, because that's the variable that you've used, and that's it, right? Now this is what we call a write function or a state changing function because it modifies the state of the blockchain. It changes something, which means it costs a tiny bit of gas to run, not much, but a little bit. Now, finally, let's write a function to read the current greeting. So we say, okay, this is only supposed to read. So we'll say, okay, greet, no parameters, and we say public. And now we'll write a view keyword. Why? Because, okay, we have done all the changes that we wanted to do. This one function is just supposed to read whatever is the output. So we say view, so that it's view only and no changes. And then we say it should return something. This function should return something. And return what? So we will specify string memory, and then we're like, okay, and then what? Return greeting. Wow. Simple. Okay. So now we know, anyone can call it. It does not take any parameters because all it does is tell you what the current greeting is. This function does not modify the blockchain state at all. It only reads data. It's like looking through a window versus opening a door and walking through it. So one just observes, one just interacts, and now you know the return part says, hey, Solidity, this function is going to give back a string, and when we just return whatever the current greeting it, and that's all. That's our smart contract. Now, how do we actually run it? So we'll go to the base directory, and then we'll run a command called forge bit. Now, what will it do, or what did it just do so quickly, is Forge is going to compile your Solidity code into bytecode that can actually be deployed on the blockchain. You should see the output on the screen scrolling by, and hopefully at the end of it, which right now is possible because it was a simple contract, you will see something like compiler run successfully because there are no errors. So if you do see errors, don't panic. Seriously, errors are a normal part of development. Everybody comes through it. And I think the best learning thing happens when you are debugging an error. Exactly. So now, for the exciting part, but before you can deploy, we need one more thing. We need some test ETH in our wallet to pay for the gas fees. Even though we are on a testnet and it's not real money, we will still need testnet ETH to deploy contract. So let's get some. Now, if you go back to the browser, here's MetaMask, and we also have to do something else. Oh, sorry. Okay, so we are at base Sepolia network already. If you are not, you have to go to networks. You have to add a custom network. You can just look at base, testnet, Sepolia, network, info, whatever I typed. Okay, so chain list is the first one. Now it gives you certain information like chain ID, currency, gas limit, blah, blah, blah. So you can just add it in the network section and the network will be added. So right now I have certain Sepolia ETH, which is great. Now this is on the browser and we are interacting and writing the code in our local host. So how do we actually interact? Now, for this wallet, like MetaMask wallet, there's something called as private key in the account settings, which you should never really share with anybody. So you will need to enter your password. Once you do, you will see your private key. Copy it. Again, this should be a wallet. You're only using testnet, not your main wallet with real funds. Back in your terminal, go to the .env file where we added our RPC URL and write private key equals to and add your private key. Please don't show it to anyone. Don't push it to GitHub at all. Now, as you have done that, you come back here and we will try to deploy this contract because we have already sort of what? We've already compiled it and there were no errors. So let's go. I am probably not going to type the entire thing. Good. Yeah. I did experiment. Yeah. So this is the command. Forge create src greeting.sol greeter RPC URL, which says base Sepolia RPC URL. This is how the RPC URL should be given in your .env. Then you add a broadcast command, because if you don't, actually I'll show you what happens if you don't. Okay. Oh, shit. Yeah. Okay. So let's remove this. And now what? Oh, sorry. Okay. Now this part of this command is very, very important to, wow. No. I did add base Sepolia RPC URL. Okay. So I know why, so I know why this is not picking up. So for that to happen, you have to write something called source env so that it can pick up the values that you have in your .env file. But now I will show you why this command is important. So forge create is the command that you use to deploy a contract, and then src/greeter.sol greeter tells it which contract to deploy. You can have multiple. The first part before the colon is the file path, and the part of the colon after the colon is the contract name. Now, this is necessary because a single Solidity file could contain multiple contracts, and the --RPC URL flag tells Foundry which blockchain to deploy to, and we are passing it that environment variable that we actually set with our Alchemy RPC URL, like I mentioned. The private key flag is how we authenticate and sign the transaction using the private key we just set, which was taken from our MetaMask. And finally, the constructor argument is where we pass any argument that our constructor has. In this case, okay. So, yeah. In this case, yeah, it was hello world GM building the future, whatever speaks to you. I said hello base builders. So that was it. Now when we type the command and paste it, then hit enter, you will see some output. Foundry will start by compiling your contract one more time to make sure everything is good. Then it will construct the transaction, sign it with a private key, and send it to base Sepolia network. You will see some transaction details scrolling by, and then after a few seconds, when everything goes well, you should see something like deploy to 0x followed by long hexadecimal places, which you haven't seen. And why? There's a warning which says to broadcast this transaction, add -- broadcast to the previous command. So what we will do is we'll go as it was. Oh, shit. Where is... Yeah. So we've added the broadcast flag here, because if you add it in the end, it will not really work. So now you compile, no files changed, compilation skipped, and yep. So deployer, deploy to transaction hash, and this is the wallet address of my MetaMask wallet, and this is the deployed contract address. So now you have to copy this contract address because we're going to use it and interact with a contract. Now you might be wondering, okay, Sneha, I've deployed this contract, but how do I know it's actually there? How can I see it? How can I interact with it? Great question. That's where BaseScan comes in, and this is honestly one of my favorite parts. So come in, people. BaseScan Sepolia. Okay. Now, oops, I did not copy the let's copy this and let's go here. And then change it to Sepolia testnet and paste it here and woof, 1 minute ago. Great. Now we can see there is a contract section. Okay, great. But it says, are you the contract creator? Verify and publish your contract source today. Okay. So now we know that it's there. Now if you click, this is my favorite part here. So if you verify and publish, it asks for a lot of information, but I am a super command person. I like to be in the terminal. So what we will do is that we will first, actually, we will try to get it done through the EtherScan API key, and we'll see how we can do that through Foundry in our terminal itself. Okay, getting an API key. So from here, you come to account dashboard. Great. Fine. Web3 Compass has it here. If you create an account overview, but you can, no, sorry. How do I always forget how did I create one? Okay. So there is one active API which I had created, but you can add one more here. And yeah, just create your API key and then you add your API key in your .env. Okay. Is that clear? Okay, cool. So we'll do the same as we did for the other env variables and we'll paste it there. Now, what we will do is instead of doing things here, we will come here and then we have a command. Okay, let's do this. Cool. So I've copied the command from somewhere. I would also do like this. This works better. Okay, cool. So now, because I didn't want to copy it, I've lost my access to the commands that I had written in my notes. So I will just explain what this is. We use the forge verify command to actually verify the contract. We have, okay. This is where we provide the contract address. We have very carefully put in chain. Oh shit. Oh no. See? This is what happens. My bad. Sometimes when you just record things, you do stupid stuff. Okay, yeah, so I was saying, so then you specify with the hyphen chain flag, you specify which chain do you want to verify it to or where is the contract deployed so that it can have access. And then you provide the contract address. And then you have to provide the path of the smart contract. Yeah. And then you use the verifier flag, you provide the EtherScan, put in the API key, the variable here, EtherScan API key, and this is already there in your env. We have gotten those variables from source.env. And then we provide the constructor argument on what you want to pass. And I want to pass hello base builders. And then we'll just hit enter. Okay. Oh, sorry. So because we are already sort of giving the EtherScan API key, we don't want to add the URL here. And that is why it would just be a simple command. And oh my God, I removed. Uh-oh. What did I do? What did I do? Let's ask AI maybe. Cool. Let's just copy this and we want to send to chat and be like, hey, can you help me by telling me what is wrong with the command. Winsoft to our rescue. Okay, cool. So it says possible values, ether scan, you included extra missing verifier flag. So it says, okay, this is how it should be. Okay. So it says forge, verify contract, chain based, blah, 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 verify ether scan. Oh, I removed, okay, let's maybe use chain based Sepolia. Okay. Okay. Yeah. So we need a verifier, ether scan. Okay. Great. Great. We just wanna remove the contract address. I could have just copied it, but I figured out what was wrong here. So I just wanna take this away and no. Okay. I will just type it. It's a not so smart day for me. What was my address? Cool. Paste it. What? No. Let me just. Okay, did I not source it right? No. Okay. Okay. Yeah, I know. No. Okay, let's see if this works. Oh my god, why? Okay, so I did a very stupid mistake. Kept the variable name in the .env file wrong. So what? Yes, I know. I know. I saved it as BaseScan. You see? You see things I do? Yeah. Source.env and then yes, finally. So it says submit verification, and now you follow the link and you can be like open. Okay. And it says contract is verified, and now you can see the contract exactly. So success message. It took a while, but we made it. We finally made it. So you've officially taken your first real step into building on Base. And this foundation we built today is absolutely crucial for everyone else and everything else that we're going to do in the series. Every dApp, every protocol, every Web3 application starts with smart contracts, just like the one we deployed today. So you not just got to know about Base in general, but also how to write a contract, use Foundry, and verify it on BaseScan. In day 2, we're going to learn how to build a front-end application that actually connects to a user's wallet and interacts with our smart contracts. We will use this amazing tool called onchain Kit, which is specifically designed for Base and makes building onchain applications so much easier. We're going to bring our contract to life with a real user interface that people can actually use in their browser. No more interacting through BaseScan, or we're building a proper web app. So get ready because it's going to be awesome. If you've enjoyed this video and found it helpful, not hopeful. I really hope you did. please support our program, build mini apps. That's what we want. And let more and more friends know about Web3 Compass and Dev3 Pack and base in general. I would love to hear from you in the comments. How did it feel when you successfully deployed a contract? What is the greeting message you chose? And if you ran into any issues or have any questions, I'll try to read all comments, but you can also hop on to Web3 Compass Telegram group, which is here, or Dev3 Pack's Telegram group, and ask questions. Thank you so much for watching. I genuinely can't wait to see you in day 2, where we build our front end. Until then, keep building, keep learning, and yeah, base builders we are. Bye, guys.